So, list of properties. We need this before we can start our proofs. First one is the commutative property, which you guys should know from before. Commutative property basically says the order in which you add or multiply doesn't matter. Okay, that's why I have them both right there. So, an example in algebra would be x plus 3 is the same as
3 plus x.
Thank you, 3 plus x. Okay, if we're going to work in geometry land, the measurement of angle A plus the measurement of angle B would be the same as the measurement of angle B plus the measurement of angle A. Okay, the order in which you add or multiply does not matter. Now, in the word commutative, what word do you see? Okay, what else? What's that word? Commute. All right, you guys commute to school every single day. Commute to school, you commute home from school. Okay? Think about it. The distance from your house to school is the same as your distance from your schoolhouse, right? So the order in which you travel doesn't matter. It's still the same distance. Does that make sense? So think about commutative property. Think about a commute. The way there and the way back is the same. Associative, this is the one with grouping. The way in which you group an addition problem or a multiplication problem doesn't matter. For example, a geometry example. So in these examples, all you're switching is the way that it's grouped and who gets added or multiplied first. In the word associative is the word associate. Who you associate with is essentially your group of friends, right? Okay. So for example, if Anna, Beth, and Casey were going to the mall, right? If Anna and Beth drove together in the same car and met Casey, or if Beth and Casey drove in the same car and met Anna, doesn't matter how they got there, right? Aren't all three girls at the mall together? Okay, so associative is who you associate yourself, who you group yourself with. The order in which you add or subtract with the grouping, or add or multiply with the grouping doesn't matter. Reflexive, this one is probably new for you. In the word reflexive, you think of the word what?
Reflect.
Reflect. So think about it. You see yourself on the other side. So a nice algebra example. Geometry example. Distance from A to B is equal to the distance from A to B. Okay. Right now it's kind of like, well, why would you do that? When we get into proofs later and we start talking about proving triangles congruent and stuff like that, it's going to be important to note that if you see yourself on both sides, or if it's something called a shared side, you're going to use the reflexive property to prove that they're congruent. So, more used with reflexive later. Symmetric is the second one. It says if A equals B, then B equals A. So, something I want you to notice, there's two things going on. We have an if and we have a then. Symmetric gets confused with commutative a lot. So I want to make that clear right now. Commutative is the order. Symmetric is the side that it's on. And the symmetric usually has an if and a then. Okay. See, the order didn't change. The side did. A was on the left, B was on the right. Then B is on the left, A is on the right. The side of the equal sign changes. So an example would be If 2x is equal to 3, then 3 is equal to 2x. It's not the order, it's the side of the equals. Okay. If segment AB is equal to 5, then 5 is equal to the length of AB. That's your symmetric property. Okay, transitive has 3 things going on. So it kind of almost looks like symmetric, but it says if A equals B and B equals C, then A equals C. We kind of talked about this a little bit the other day when we were going through one of our always, sometimes, never questions. We said if, angle 1 is complementary to angle 2, and angle 3 is also complementary to angle 1, then 2 and 3 would be the same. That's kind of what's going on here. So what they're saying is, see how B is joining both? B is equivalent to A and B is equivalent to C. Notice the letter B is on either side of the word and. Okay? They have that thing in common. Therefore, you can say there is a relationship between A and C. Okay? Example. If Jamie is Kevin's brother, and Kevin is Courtney's brother, what would be the relationship between Jamie and Courtney? Brother and sister. Right, they're siblings. Why? Because they both were related to Kevin. They had that commonality in the middle. Does that kind of make sense?
Wait, so you're saying, what if they have like different parents, like different moms?
Well, if they would still be considered step whatevers.
Oh, okay.
Right, that's okay. But even if, say, it doesn't matter, stepbrother, stepsister, half-brother, half-sister, you're still considered siblings, right? So example would be, okay, if x is equal to 3 and 3 is equal to y, notice 3 is on either side, then x and y have to be the same. Okay. Geometrically, if the measurement of angle 1 is equal to 90, and 90 is equal to the measurement of angle 2, then the measurement of angle 1 has to equal the measurement of angle 2. They're the same thing. Again, you can see they have 90 on either side of the word and. Questions? Alright, so they should be probably the 3 new ones to you. And now we're going to go back to some review ones. Substitution. Okay, this is your replacement property. So for example, if segment AB was 10, and say AB plus BC is equal to 30, you can take that 10 and replace it right in. Then 10 plus BC would have to be 30. We just substituted it in. Notice, I did use an if and the then here. However, look at the word and the stuff on either side. This time is the same thing on either side of the word and. No. This is a replacement. This is substitution. All I did was plug something in. A little bit different than showing that relationship with transitive. Okay, and good old distribution, yes. Yes. Good old distribution. We did this earlier today. Just distribute it. Okay, you take what's outside and distribute it to everything on the inside. What's the operation we use with the distribution property? Multiplication. Good. All right, questions on those properties? Yes? Mm-hmm. Alright, and your lid sponge. We have our addition, subtraction, multiplication, and division properties. For addition, we talked about adding the same thing on both sides, keeping it balanced. Subtraction, subtracting the same thing from both sides and keeping it balanced. Same with multiplication and division. When you write these down, we're going to flip your paper over and we're going to utilize them. See if we can pick them out. Alrighty, so these are your options. Okay, gave you kind of like a little word bank almost. Let's look. If xy equals OP, so that means the distance from x to y is the same as the distance from O to P, then OP equals xy. Which one of those properties that we just talked about would work? We're not adding or multiplying anything, so it can be commutative. Do you see yourself on the same other side?
No.
Do you see yourself on the other side?
No.
It has an if and a then, and the sides of the equal have changed. Symmetric. Very good. So it's letter D. Number 2. What did we just do to both sides to get from here to here? How did I get rid of the minus 8 to minus 8? Right. I added to both sides. So which property is that? Adding 8 to both sides. Adding the same thing to both sides. No. Adding the same thing to both sides.
No.
Adding.
H.
Thank you.
Welcome.
Addition property. When you add the same thing to both sides to get it out of there, that's just your addition property.
I see.
That's what we use when we solve our equations. Yes.
Let's do number 3.
Okay, what do you got?
Reflective.
No, because we don't see ourselves on the other side. The order's changed.
Oh,
There's your commutative. Right. Reflective, you really need to see like a reflection in the mirror. Okay, how about number 4?
Transitive.
Good. I have 3 things going on, okay? And if you look at the word and, the same things on either side. That's your transitive. That's letter E. All right, how about number 5? What was that? Right. There's 3 things going on, but if you look at the word and, is the same thing on both sides? No. The left has 100 and the right has that measurement of angle too. So it's not the same thing. All we did was take this original problem and plugged in 30 for angle 2. So when you're plugging something in or replacing, it is substitution, which is letter J. All right, number 6. There's your reflexive. Very good. Number 7. Good. Number 8. We're not adding or subtract, or adding or multiplying. Can't be commutative. There's not 3 things. There's an if and a then. Symmetric. Very good. The order in which angle 1 and angle 2 were flipped around. 1 was on the left, 2 was on the right, then 2 was on the right, 1 was on the left. How about 9?
E.
Which is which property? Associative. Good. And division. Right. So that's I division property. You have to divide both sides by 3 to get that answer. Questions?